This is part 1 of our geometry review. So our question here says, solve for the marked angles in each of the following diagrams. So I have a rather complicated looking diagram that has letters A, B, C, D, E, and X labeled, and that's what I would like to solve for. So we're going to try to work our way through and see how many of them we can find. Some of them we can probably find without having to calculate other angles. Some of them we need to calculate other angles first before we can find them. So first thing I would do is try to look and see if I see an angle that it's a pattern that I recognize and maybe start there. So I'm actually going to start with A, and I'm going to use my calculator case to cover up the rest of the picture. I have 135 degrees and angle A. If I look at my geometry theorems, right, I am looking to see if I have anything on here that matches that. So I see a straight line that is broken up into 2 angles. Here, I have a straight line that is broken up into 2 angles. That is the supplementary angle theorem, and it says that those 2 angles add to 180 degrees. So under theorem for A, I'm going to write SAT. This is the supplementary angle theorem. And these 2 angles should add to 180 degrees. So I'm going to write that A plus 135 equals 180. And then I'm going to solve for A by subtracting 135 from both sides. And 180 minus 135 is 45 degrees. And then there is a place for me to put my answer of 45 degrees. Okay, I also recommend labeling it on your picture because we might need to use that angle in order to calculate another one. Okay, I'm looking at my diagram and I am drawn to angle B. So I see that angle B has another angle on the outside. It's a reflex angle because it's quite large, of 230 degrees. So I'm going to look to see if I see something that matches that on my theorem sheet. And I do notice this one has an angle and then the circular angle on the outside. That is RAT, the reflex angle theorem, and it says that those 2 angles make a full circle, so they add to 360 degrees. So I'm going to say that for B, I'm going to try using the reflex angle theorem, or RAT, and that those 2 angles, B and 230, should add to 360 degrees. So B plus 230 equals 360. And then I would subtract 230 from both sides. And then 360, take away 230, is 130 degrees. Okay, I'm also going to label it on my diagram, because I might need it to calculate another angle. Okay. I'm looking, I could continue trying to go in alphabetical order. I also think I might be able to calculate angle E, but I think we're going to try going in alphabetical order if we can. So angle C is up next. I notice that C is part of a 4-sided shape. 4-sided shapes are called quadrilaterals. I have a theorem on my sheet that says when you have a quadrilateral, the angles add to 360 degrees. That is the sum of the angles in a quadrilateral theorem, otherwise known as SAQT. So I can take these 4 angles, add them together, and make them equal 360 degrees. So I'm going to write for C that I'm using SAQT, and that C plus 112 plus B, which is 130, plus A, which is 45, all together make 360 degrees. I'm going to collect my like terms. So the 112, the 130, and the 45 I can add together. That shouldn't be an equal sign. It should be a plus sign. All right, 112 plus 130 plus 45. I got 287. Yep. And that equals 360 degrees. And then I'm going to subtract 287 from both sides. And I get 73 degrees. Okay, I am going to label that in my diagram. This is 73. Okay, if we try to continue in alphabetical order, D is on the opposite side of 73. So if I were to cover up the other parts of the picture and just look at C and D, I see two crossing lines. This is my personal favorite of all theorems, OAT. OAT says when you have two perfectly straight crossing lines, the angles on the opposite sides of those two crossing lines should be equal. So that means that angle D should be 73 degrees because of OAT. So down here for D, I'm going to write that we're using the opposite angle theorem, or OAT. No calculation is required for that, and it is also 73 degrees. Okay, for E, if I take a look at E and 28 degrees here have a little square in the corner, meaning that they make 90 degrees. So if I take a look at my formula sheet, I notice the complementary angle theorem, or CAT, says that two angles with that little square in the corner add to 90 degrees. Sometimes there might be three angles, but all of the angles together make 90 degrees here. So that means that E and 38 would equal 90 degrees if you added them together. So for E, we are using the complementary angle theorem, otherwise known as CAT, and that E plus 38 equals 90 degrees. Don't know what I was thinking. All right, I'm going to subtract 38. $90 take away 38 is 52. So E equals 52 degrees. All right, we have one last one to do here. So I know now that E is 52. I just need to find X. So X is part of a little triangle here. So if I cover up the other parts, right, there's just a little triangle there. There are three different triangles on my formula sheet. Now the first one has tick marks. Mine does not have tick marks. That means all the sides are equal. My triangle, all the sides are not equal. This one has two tick marks. Mine does not have any tick marks. And then this one is just a triangle without any tick marks, and it says that the three angles should add to 180 degrees. That is SATT, or the sum of the angles in a triangle theorem. So I'm going to use SATT, which says that X, D, which is 73, and E, which is 52, should all add to 180 degrees. I would collect the like terms of 73 and 52, which is 125. That equals 180. And then I would subtract 125 from both sides. So 180 take away 125 is 55 degrees. Okay. So that's it for question number 1 on our geometry review.